So I think now I will switch to English for Giovanni and Ansaloni. So I will present in a few words. Giovanni is a scientist at the Laboratory of Embedded Systems of Professor David Atienza. This laboratory has, among many other things, organized contests. In particular, in one of them, the students had to create a Nintendo DS game. And that's why I wanted to invite Giovanni. Thank you very much.
Thank you very much for your nice introduction and, of course, for inviting me today. So I will spend a few words on another course that we're offering as the Embedded System Laboratory, which is the laboratory on apps development with tablets, smartphones, and smartwatches. So the course itself is offered in a number of programs at EPFL for the electrical and electronics engineering, microengineering, Internet of Things, and STAS China minor. You can find a lot more information on the course book page of EPFL. It's 4 credits, so 4 hours per week for 14 weeks, but students usually devote quite a lot of their own time for that just because mostly they like the topics that we cover and they want to explore around. So the course is organized in 2 parts. In the first part, we have 4-hour sessions, 1 hour of theory and 3 hours of labs. And in the 1 hour of theory, we cover different topics related to developing an Android app. We start from the really simple, what is a graphical user interface, and when we add more and more elements to make Android apps richer inside a single device, and then we branch out towards the cloud, towards interfacing with other devices, creating databases, managing Bluetooth connections, geolocalization, Google Maps, and so on and so forth. Aside from this 1 hour, we have 3 hours in which we go through the guided development of an app. So in the first week, we just have a very simple hello world splash displayed on the screen. And by week 8, we have a complete sport tracker application, which is interactive with a rich graphical user interface distributed among different devices, including smartwatches, ECG belts, and so on, and communicating with the cloud. So it's quite a lot of ground that we cover in just 8 weeks, but it's only the start of the thing. Because actually, in the following 6 weeks, the students are in control of their own app, and they have to devise it, develop it, and present it to us at the end of the project. Actually, most of the evaluation of the project is based on the app that the students developed in groups of 3 students. And we have different projects that we propose, and students are also welcome to come with their own project and propose it to us. And here is where gaming comes in, because on one side, one of the topics that we propose is distributed and interactive gaming, and on the other side, irrespectively of the topic that they choose, what the students are tasked to is to game around with different devices and just run wild with all the knowledge that they have acquired in the first part of the course. Among other things, students can interact with flying drones, they can have augmented reality applications, and many interesting stuff, including artificial intelligence, video conference tools, and so on and so forth. Really, the sky is the limit here. And this is made possible because I am part of a really great teaching team. So I'm mostly in charge of giving frontal lectures, but the students support in their gathered project in the first part and their own free project in the second part is actually straight on the shoulders of Halima, Saleh, Farnaz, Renato, and Alireza. And just let me spend a few seconds to thank them for their great effort and the great results that we had in the past with this course. So just to give you an example of an application that students came up to, here is the Trivia Go app, which was developed by Teofan, Basile, and Lawrence in the last year. And it's a collaborative and geo-based game in which there is a game master, which creates a game by placing different waypoints on the map and placing questions on the waypoints. Then players can join the game, so they have to go to the waypoints, and only there they can answer the questions. To realize this game, you need to have an interfacing towards a distributed database to realize the question database and the individual game. And as another point, the students also interface a tablet with a smartwatch, which works as a compass to guide the navigation from waypoint to waypoint. So this is a video that the student themselves realized to present their project. So this is the main screen in which the gamers can look at the rules of the game, and then the game master decides what is the name of the game, the number of players which are allowed in a match, the type and the number of questions and their difficulty, and then the game master again places waypoint on a map. So since you have a knowledge of EPFL, maybe you should know where these rooms are, but waypoints can be placed anywhere in the world, basically. Then the type of questions in each of the waypoints, for example, general knowledge, in this case, mythology, art, and all these are grabbed from a database in the cloud. Once this is done, players can join the game. So they enter their name and the game that they want to join. They have to wait for all the players to join, and then the game starts. What gamers see is the map, and they have to navigate to the proper location. All of this was developed by the student themselves, not by us. And they can navigate using the tablet, and for a split second, you have seen that there is a compass on the smartwatch. Here, they just provide answers to the various questions of the quizzes, and then they can navigate to the next waypoint. So this is a correct answer. So apparently saffron is really expensive, and this is the stats which are collected at the end of the game. This is, you can see at the bottom of the screen that there is also the compass in the smartwatch that helps the navigation, so players don't have to take their tablet in order to navigate from waypoint to waypoint, and that the application is robust towards rotation of the tablet device. So before I end, so what we learned from this course here. First of all, it's a lot of work because we have to prepare lectures each year so that different projects are proposed to students, and we never replicate the same project 2 times. And also we have to keep up with a moving target because Android is moving really fast, and we want to provide up-to-date material to the students so that they can learn how to program up-to-date apps. But this work really pays off because we have a really nice feedback from the students, especially again regarding the disponibility and the work of the TAs. So it's really gratifying to us. And I have to say that even students are really gratified by the knowledge that they acquire. this ends this brief presentation. So if you're interested into the course, please subscribe to that, and I hope to see many students in the next semester join it. So thank you very much for your time, and I'm now ready for questions.
Thank you very much for this presentation. I will start with a question about the course and the place it has for students. You said that students were interested by developing video games, and it's very interesting here because we also give a course where we create video games, and students spend a lot of time, more times than the credits corresponding to that in creating games. But at the same time, they are reaching the objectives of the course, but also they are learning to create games. They are gathering some of this knowledge. So my question is, what is the place for game design or knowledge about games and maybe user interface and about how to design a game and design goals in your course? Is it something that they bring to the course, or is it something that you thematize?
First of all, we propose projects that are games, but also some projects which are not. For example, we propose wellness applications. We propose distributed applications, and so on and so forth. We also propose gamings, and we find that usually this is a nice motivator for them to explore things, because we provide basically the bricks, which then they have to use to build a new building by themselves according to what their interests are. And if you like what you're doing, you're usually well motivated to do well. What I can say is that we had multiple cases of students asking us if we could own the code so that we could further improve our app and then distribute it, monetize on it, etc., which is something that we actually encourage. Another outcome of the projects is that we interface that with our own research activity and the embedded system laboratories. For example, we have a whole track of research on biosignal analysis, so we can interface wellness application to this type of analysis. And then whatever you're doing with drones, well, it always becomes a game. So if you have a flying thing, it's a game by itself, isn't it?
Yeah, thank you for this very complete answer. Yeah, I really like the fact that we this event is dedicated to the members of the campus doing research, but also to the students. As Nicolas was saying before, they are pushing for this kind of content during their studies. And yeah, I thank you in their names for providing this possibility in your different courses. Thank you very much for this presentation.
Thank you.